Intro Algebra Lesson 5-1b, continuing our theme and looking at slope and how we might be able to write equations based on some graphs. I first want to look at some real-life scenarios involving slope. So here we have the steepest cable car route in San Francisco is supposed to be a 22% slope, which is between gentle to moderate to steep. So it's fairly steep, and as you look, that's the slope we're talking about heading down. If it was all the way up here, that'd be quite steep at 100%. Alright, so flat to gentle is down to the 10%, hardly any slope at all, and as the steepness of the incline goes up, the more steep it's considered to be. In other words, the steeper the slope, or the higher the slope. You would have more change vertical than you do horizontal. So for every horizontal movement, you're really going up quite a bit. That makes it much more steep. Here's a look at some slopes of some brownstone apartments in New York or somewhere. You can see the slope of the banister for the staircase. And if you think about the stairs, they sort of fit the rise over run concept. So they're going up and over at the exact same amount. In this case, if we were looking at them, they would be considered a negative slope as they go down. But again, this slope is what we're thinking about, that it's following. The banister is following that exact same slope. Right? This little device measures the actual angle of elevation that we might have on the pitch of a roof. So different roofs have some different pitches. Here you have the rise in inches compared to the actual 1 foot. So the roof pitch symbol, 12 and 4, it's saying that for every 12 inches that you go to the right, you would go 4 inches up. So here, right here, this is a 12 and a 1 inch up. Here's 12 inches for 2 inches up, 3 inches up, 4 inches up. And you can see that if you actually go 12 inches over and 12 inches up, then you really have a rise of 12 over 12, which is the same as 1. And there's all different kinds of roofs that have different types of pitches. For example, here's a 2 and 12 pitch. That means for every 12 inches it goes to the right, it's going to go 2 inches up. So it's not very steep. But then that doubles. Now it goes, for every 12 inches to the right, it goes 4 inches up. So it's going to go a little more steep. Then 5 and 12, for every 12 inches to the right, it goes 5 inches up. 6 and 12, so for every 12 inches to the right, it goes up 6. 7 and 12, 8 and 12, a 9 and 12, this is a 10 and 12 pitch, and then this is a 12 and 12 pitch. That means for every foot it goes to the right, it goes 1 foot up. So that would literally be an up 1 foot, over 1 foot, up 1 foot, over 1 foot, following that slope. So different pitches of the different types of buildings. Maybe in the region you were living in, it doesn't have very much rainfall, so you don't need much of a pitch. If there's a lot of snowfall, you might want a steeper pitch so that the snow falls off of it. And then sometimes it's just for the aesthetics of how it looks. So, we have learned in the past that parallel lines have exactly the same slope. So in this case, we want to write equations for each one of these 3 lines. We need to know some important pieces of information. For example, we need to know that right there is a y-intercept at 1, 2, 3, 4, 5, 6, 7. And this is a y-intercept at 1, 2, 3, 4. Right there. And the red line has a y-intercept at -2. So now that we know all the y-intercepts, what's important to know is we've got to figure out the slope. Well, it appears as if the slope goes up 2 and right 2, 4. Up 2, right 2, 4. Up 2, right 2, 4. They all appear to be going up 2 and right 4. Up 2 and right 4. So 2 over 4, that means that the slope, 2 over 4 is the same as 1/2. And they are parallel, so all 3 of them have the same slope. So when it comes to writing the equations, you'll have y equals 1/2 x plus 7. You'll have y equals 1/2 x plus 4. And you'll have y equals 1/2 x plus -2. Because all 3 equations have the exact same slope, because they're parallel, they just have different y-intercepts where they're crossing the y-axes. Again, the 2 most important pieces are the y-intercept and the slope needed in order to make our equation.